God is in control. God knows exactly what he's doing.
Come inside and you kill me if you have to. I'm gonna sit here with my Bible.
Wouldn't even try to fight back, run, nothing.
Oh, I would fight back probably. I got God on my side. So probably don't. I'll throw the Bible at them.
It's a really big book.
Yeah, it's strong.
Okay, so it says she's joining. Let's see if we can roll.
And throw a cross just in case.
I don't have a cross, but I can find one.
The only thing I can't watch is NBA basketball. It's like they're making like $50 million a year, and then they're like, "Oh, we're friends, That's all." And they want to like just cancel games because they're like, "We just want time to think." It's like, bro, it's like
College basketball.
I don't even really like college basketball.
What? College is way better than NBA.
No, I'm not saying it isn't. I'm just saying
I know
I
what
watch
I'm
college
ratio. When we were doing, I was doing the homework from mixed review, and I saw the ratios, I was like, I love that. And now we're doing it. Again.
There we go.
I just rewatched mine the other day.
Catch up on it.
No, because they like say all of them.
I watched
All right, good morning, Keely. Sorry, I was late, then the computer's struggling to link up, and so here we go. I get ready and share my screen. Wrong button.
That was my Bible for a long time. What am I in the
This math thing working.
What about like this one? You'll be
Yeah. Be like, yeah.
All righty. So what we're going to do is we're going to start reviewing and answering any questions that we have so far on our homework. Turn this
Yeah,
No, we were beating first.
get a little bit better. All right, so we're looking through. Let's do go back. Like I said, so I'm going to kind of use this as a time to review everything we've talked about. Go ahead and get your notes out that we've been taking. If you've got blanks to fill in, we can work on filling those in. So go ahead and use this time to get your homework organized. Have 7-1, then 7-2, 7-3, 7-4. Yes.
Found fake, but my dog ate 7-5, 7-4, 7-2, or all the notes.
You need to start taking pictures of.
Okay. So I think you've already had an issue with your dog eating homework before.
Yeah, no, that was last year.
No, that was this year. I've already heard that one this year. So unfortunately, you're gonna have to do it again.
Extra practice, even if you did extra
Because
practice.
I just to be able to grade it, I gotta have it to.
Okay, my homework is
So you need to make sure you're putting it somewhere where the dog can't get it.
So he jumped on to the chair while I was in Zoom, and jumped up to the desk, and grabbed his notes, and ran.
While you were zooming.
No, after.
So, okay.
Ask his mom.
So where can you put them to keep him from getting them?
On the top shelf.
It's like a mini Jack Russell Terrier.
Joe Biden.
Um, Just thinking somewhere hard.
Mhm.
I'm 33 miles an hour.
Okay. So 7-1. 7-1. we started talking about motion in a coordinate plane, okay? We started talking about how when we have a figure in a coordinate plane, that sometimes those figures can move, okay? So that's what we're gonna start looking at, and I'll zoom to make the picture a little more clear. All right. Grab my pen. I do have a whole bunch of papers to pass back. Probably have to get into those and get them ready. Okay, so talking about rigid motion in a plane, we talked about how our original image, our original picture, our original plane is called our pre-image. And then after it moves, now on in the chapter, we even talked about how sometimes we have turns. So we go from our image, from our pre-image to an image and then to another image. And then the way that we talked about how we're able to discern which is our pre-image, which is our second image, which is our third image, is we use the prime symbol. So remember, a single letter indicates that it is the pre-image. So if I have without the prime symbol, that's my original image. And then once I have my additional point, I use that prime symbol to indicate that it is my image. So pre-image, no prime symbol, image, prime symbol. Then if it has a second motion, then it's indicated with 2 prime symbols, okay? So that's kind of knowing about the prime figure. What are our 3 types of motions? What are our 3 types of transformations?
Reflection, rotation, translation.
Reflection, rotation, translation. What is another word that we can use to help us remember what a reflection is? Mirror. Good, that's one word we can use. Is there another? Starts with an F. A flip, okay? A mirror image, a flip is going to be my reflection, okay? What about a rotation? What's another word I can use to remember what a rotation is? A spin, good. What's another word that starts with a T? Turn, yeah, turn, spin, all right? So kind of using words that help us to remember what that motion looks like. I can hear rotation, but then I go, okay, it turns, it spins. And then our last one is a translation. And what do we say that looks like? A slide or a glide, okay? So think about if we walk in, I know my kids love to walk in and stop real fast on the hardwood floors and just slide forward, okay? So think about, you know, they stop and then they slide. Now, we learned about these, all 3 of these types of transformations are called a certain word because when they move, when they have motion, they have the same exact size, the same exact angle measurements. Everything stays the same as far as the makeup or the size of the figure. What is that word that says everything stays the same from pre-image to image? Isometry, good, okay? So isometry means it stays the same, okay? It holds its shape. So that's what an isometry is. Now we keep on going. And I'm going to move on to 7.2. So look at 7.1 homework. Be sure to ask any questions if you have them as we do a section. So 7.1, does anybody need to fill in any 7.1 notes or any questions about 7.1 homework? Number 33 on 7.1. Let me get to that page, 7.1. Page 400. Number 33. Okay, so it says show the transformation is an isometry by using the distance formula to compare the side lengths of the triangles. So let's think for just a minute. What is my distance formula?
Isn't it my gosh.
It is
V equals x2 minus x1.
Square root of
Distance is the square root of
x.
minus x2 minus x1 plus y2 minus y1 squared.
I hope my friend would homework the other day.
Okay, so I know that I'm going to have to use my distance formula here. So I'm going to have to use my distance formula for each segment. Okay, so I'm going to have to actually do my distance formula 3 times here. because, actually 6 times. Well, no, I lied. We don't have to do it for one. Which side do I not have to use distance formula for? No, this A to C. Count my units. From A to C, I can start at 4 units. So I see from A to C. From A, I go 1, 2, 3, 4 units. Okay, so I can see that those sides are the same. I don't have to use distance formula. So as long as it runs along lines of my coordinate grid, I can just count it. I'm going to have to do distance formula for B to C, and then I'm going to have to compare that to Z to Y. Okay, so I have to distance formula here. And what did you find the distance of B to C is?
Square root of 8. That's what I got.
Okay, you're close. So let's take a look at that. If I go from B to C, what is my ordered pair for B?
2 minus 1 or
Okay, so let's look at point B. I'm from the origin, remember? I'm going to the left, 1, 2, 3, 4, 5. So that's -5, and then up 1.
yeah, so -5.
-5, 1. And then what about C? C is 1, 2. So I'm at -2, and then I go up 1, 2. -2, 2. So remember, it does not matter which one I pick to be X2 or X1. It just matters that I use the same ones from the same ordered pair. So I'm going to have D is equal to the square root of, I'll use the bottom one as X2. So I'm going to say 2 minus 1 squared plus -2 minus a -5 squared.
Where are you getting that from?
Okay, so I'm saying that this 5,1 is X1. Okay, so do you see how we said that B was -5,1?
Okay.
And C we said was -2, 2.
Yes.
So I said that this is going to be 0.1, X1. Let me turn where you can see this a little better, Keely. There we go. So I'm saying that this is X1, this is X2. So now in my formula, X1, X2, 0.1, 0.2. Let me fix that real quick. So I'm saying that this is 0.1, this is 2. So now everywhere that I see Y2, that is coming from 0.2. And everywhere I see X1, XY1 comes from 1. So I use the X value of 0.1. So 2, notice I said 2 minus 1. Except for I started words is what I did. I did Y instead of X. Let me fix that. It doesn't matter since we're adding them together in addition to commutative. Okay, so X2 is going to be -5 minus, and I'm sorry, -2 minus a -5 squared plus Y2 is 2 minus 1 squared. Okay, so X1, Y1, X2, Y2. So I plug them in. X2, subtract 1. So I've got -2 minus a -5. Because -2 minus a -5. There's a spot right here. So think about, so I've got, sorry, I'm gonna have to get something. We gotta clean this board. We gotta figure out.
Yeah, I was like, "Ooh."
All right,
My adrenaline's rushing.
all right, try this again. I will not lean on that board.
Yeah.
Okay, so we said -2 minus a -5 is going to be 3 squared plus 2 minus 1 is 1 squared. So what is 3 squared?
Would the 2 be on the outside of the 3 or?
Yeah.
Okay.
So what is
3 squared,
3 squared?
9.
9. And what is 1 squared?
1.
1. So that's the square root of 10. So you were close. You had square root of 8. Did you?
What I did was I had 1 squared plus 3 squared, and I added 1 plus 9. I added 1 plus 9, and I got 8. I guess I was small, or I don't know what I'm.
Okay, so you had it all written right. You just did a calculation error.
Yeah.
What about for the segment that we're comparing it to? So now we're comparing, that was BC. Now we have to look at ZY. What did you get as the measure of ZY?
I don't think I did ZY. I did AC and AB.
Okay, so you have to do each segment to be able to compare every single side.
Okay.
So this side was the square root of 10. This side's going to be the square root of 10. We've already said that this side was 4 and this one was 4. And then AB is going to be, what did y'all get for segment AB? 3 times the square root of 2. Good. Now, what did you get before you converted it to 3 times the square root of 2? Okay. So think about one of the things about radicals is you have to simplify them just like you do fractions. Okay. So if you ended up with the square root of 18, that is not in simplest form. So I will count off if you do not reduce, just like I do with a fraction. Okay. So I'll count off a point for not reducing. So basically, the square root of 18 is 2 times 3 times 3. So my 3, I've got 2 of them, so that comes out as my whole number, and I'm left with the square root of 2 inside the radical. Okay, so if you don't remember about reducing radicals from Algebra 1, that's going to be something you need to brush up on. Also, that is going to be something that if and when you take the ACT, they put all of their answers in simplest form. So if you do not know how to simplify fractions or radicals, you're going to struggle with that on the ACT. Okay, so it's better as you learn something. The whole point is not to learn it for the moment and forget it. You've got to keep that in you've got to remember how to do it. Okay, so for number 33, we found that AB is congruent to or equals XY. And those sides were 3 square root of 2. We already found that AC was equal to XZ, and those both equaled 4. And then BC equals YZ, and those were the square root of 10. Okay, so if you need to go back and fix those, huh?
Did you say YZ?
Because it was BC and YZ were both the square root of 10. Any other questions from 7-1? Okay, let's flip to 7-2. So in 7-2, we started specifically talking about reflections. And we talked about how a reflection, again, we can call it a flip, we can call it a mirror image, whatever we want to call it. It can reflect over a line, or it can actually flip over a point. Okay, so sometimes it's if the point is off the line, then I know that I need to count what my distance is from the original, from my pre-image to the line. I count that distance and I use that same distance on the opposite side of the line to be able to make my image. Okay, so especially if it's on a coordinate grid, I'm just counting and saying, if I'm reflecting over this line, how many places, how many units does it take to get to my line of reflection? Therefore, I have that many places on the opposite side because it has to be equal. It's a mirror image, okay? So in this one, or if my actual point is on the line, when it flips, a point flipping just still looks like a point. It's the same as an equal sign flipping, it just looks like an equal sign. So I'm not necessarily going to see a big change when my point flips over the line. It's just going to be indicated by my single letter for my pre-image and then my letter with prime for my image, okay? We also talked about how we've already mentioned that they are isometries. So let's go ahead on page 406, then we have lines of symmetry. Lines of symmetry are, oh, Lucas, who are we texting? So lines of symmetry tell us that how many lines can I draw to where I've got that mirror image, okay? So when we looked at a hexagon, it depends on the shape of the figure to tell how many mirror images I'm gonna have. I can go vertically, I can go horizontally, I can go diagonally, depending on if it's going to give a mirror image, okay? Now, one of the things we talked about, moving along, when we talked about our reflections in a coordinate grid, again, we have to look and see when we count how many places each point is from my line of reflection, and that's how I determine where it goes over that line. Now, in this section, we typically dealt with reflections over the X and Y axis. But in our most recent homework, we also looked at how sometimes maybe we had a line that was y equals 2 or y equals -2. So one of the things that hopefully you can remember, you can recall, and if you don't, you look back, is think about if I have an equation of y equals 2, okay? What kind of line is that going to be? Horizontal line. So one of the things that you can remember is if it says y equals 2, and I know I'm dealing with a coordinate plane, then I can always just plug in and say, even if I don't remember if it's a horizontal or vertical line, if it tells me y equals 2, then I know my 2 is going to go in that place of my ordered pair because it says y equals 2. And so for so if I do not have an x value, what is x? 0. So I can always go and graph the point 0, 2, and then draw my line through, and I can go, hey, that one is going to be horizontal. If I have x equals 2, again, if I don't remember what it is, I can plug in 2 for x and put 0 for y. I plot my point, and that's where I draw my line through, okay? So sometimes our directions will tell us a reflection over either the x or y axis, but sometimes it tells us we have a certain line that we've got to draw. Again, we look to see how many units does it take to get from one point to my line of reflection, then count that many in the opposite direction to be able to plot the point. So whether it's a segment, a triangle, whatever it is, I do it for every single point involved. Any questions from homework 7-2?
Number 49.
Number 49 on 7-2. All righty, so on this one, I did the example of 48 as a sample for you in class, and so let's go ahead. So basically what I'm doing, what does it mean when we talked about it's an isometry? What does that mean? Equal to shape and size. My angle measures are the same. My segment lengths are the same. So if I start with my segment, that is 13 units. Which side does that equal? What side corresponds with this one right here that's 13?
2u plus 1.
2u plus 1. So what is my equation to say that those are equal to each other?
2u plus 1 is equal to 13.
There you go. I just set them equal to each other. 2u plus 1 is 13. I subtract 1, so 2u equals 12. Divide by 2, and u equals 6. Okay, I've got 3w is equal to what?
15.
15. 3w equals 15. Divide by 3, w equals 5. Okay, and then finally, 5v minus 10 equals 19.
I want to say 15 added 10, 5v.
5v equals 29. Divide by 5. So what does v equal?
5 4/5.
Okay, so 5 4/5. So you could either leave it as a fraction, put it as a decimal, however you want to do that. Okay. Any other questions from 7-2? All right, rolling right along. Let's look at 7-3 rotations. So now we're focused on rotations. We said that a rotation is a turn, a spin, but basically with a rotation, I have to have a point of rotation. Okay, so if my figure is away from my point, then I can draw lines to my point of rotation that forms an angle. But if my figure is in line with my point of rotation, then I can draw lines again that makes one angle. Okay, Easton?
I run to the restroom.
Sure. Again, a rotation is an isometry, and also whatever my rotation measurement is, notice it says number 1 here If Q is not point P, meaning my point of rotation, then QP is equal to Q prime P. So the measure of that angle is now X degrees. So my one angle here from Q to P to Q prime is X degrees, and it is the same degree measure as R to P to R prime. Each degree measure is the same. All right, so moving along, this is where I just talked about that if it's a segment or a figure that is away from my point of rotation, I can join each point to my center of rotation and connect it to the prime point to make angles. If they are linear, then I have one angle, but if my point is actually, if my image actually lies on, or my pre-image and my image actually lies on the point of rotation, then again, it's going to be one angle. Moving on, we talked about theorem 7.3 says that a rotation can also be looked at as two reflections over intersecting lines. Okay, so if my lines intersect, then I can see where AB reflects over line K, and I have A prime, B prime, and then it reflects again over line M, so I have A prime prime, B prime prime. But we can see that our figure here just looks like it just turned and ended up here. But we can also break it down, and it would also be two reflections. And so since one reflection would be the measure of X degrees, because it reflects twice, then it's 2X degrees. So I can look at this and say, hey, if the measure of one reflection is X, then the measure of two reflections is 2 times X. Okay, so I have to remember that. So in this example here, it says the measure of one reflection was 60 degrees. So 2 reflections will be 120. So the measure of my total rotation is 120 degrees. Rotational symmetry. This is basically if I have a figure and I were to draw a 180 line through my figure, I'm looking to see at what degrees it rotates. Does it keep that same symmetry? So if I rotate it 45 degrees, does it look the same as it did when it was original? If it's rotated at 90 degrees, does it look like it did when it was rotated? If it's 180 degrees, is it the same? So rotational symmetry is, can my figure be rotated 180 degrees or less and keep the same look that it has in the original? Okay, so if we look in our box at 0 degrees, I can see where my red line is, but when I go 0 to 45, those look different. But when I go from 0 to 90, they look exactly the same. Okay, so that's what we're talking about with rotational symmetry. Can it be mapped onto itself? Okay, so let's move on to our homework in 7.3. Any questions from 7.3?
31, 33, and 35.
Okay, so let's look at 31. Okay, so again, we're talking about in 31, the angle of rotation. All right. So in 31, it's talking about how many reflections do we have in one rotation or in one reflection. Let me say that again. Let me erase real quick. When we talked about a rotation and that it actually reflects twice over 2 lines, okay, we said that one measure is X, right? So if X equals 15, what is 2X going to equal?
15 times 2.
Which is?
39.
So 30 degrees is my answer. Yeah, so all I do is multiply that by 2. So one reflection is equal to X. 2 reflections, which is the same as one rotation, is 2X, so it's 30 degrees. All right, and so the next one you said was 33?
Yes,
Okay, so in this one, it says, what is the measure of the acute angle between lines M and N, when the angle rotation about D is 162 degrees? So if my full rotation is 162, so basically 2X is equal to 162. Okay, so I know that 2 times x equals 162. So now I've got to divide by 2. And 16 divided by 2 is equal to 81. So basically, if I'm given one of my smaller angle measures, I have to multiply by 2 to get the total. If I'm given the total, I have to divide by 2 to get one of my degrees or one of my angle measures. And then 35.
Yes, ma'am.
Okay, so again, on 35 here, not only do we have to look at our angle measure, so notice here, our whole entire angle is 60. So what does that mean Q is? What did we just have to do on number 33?
We had to divide it by 3.
No, we divided by 2. Because remember, we said 2x.
Okay. So 2x is equal to 60.
So what is x, or actually in this situation, Q?
X is equal to 30.
Good. So Q is going to be 30 in number 35. Now on this one, since it's an isometry, again, I'm looking to see which sides correspond with which sides. So I can see here that this side here that is 11, what side does it correspond with?
The side with the blue.
Okay, so but which side of my blue figure does it? Okay, so it corresponds with S. So S equals 11. What corresponds with 3T?
The 3.
Good. So what does T equal? If 3T equals 3.
T is equal to 1.
Good. T is 1. And then we have 2U corresponds with which side?
Four.
4. So what does U equal?
U is equal to 4.
No, if 2U equals 4,
Okay.
then I've got to divide both sides by 2. So U equals 2. Okay. And then finally, I've got 2R equals 10. So 2R equals 10, divide both sides by 2, and R is equal to 5. So my answers are those, okay? Go ahead and take a 5-minute break. We will come back and finish our review of this section and finish up chapter 7. I'm gonna make a few copies.
It's just us. I really want to see how long could he might survive.
I have like been paying attention at all.
Yeah, I just know what he.
I
he's
don't.
not gonna
Like as soon as
survive
Biden was president, I was like, okay, I'm turning off the news.
Yeah, I haven't been watching it. My mom's been watching it, so like I don't have a choice. I have to hear it.
Yeah. I hear my mom having a conversation with my dad about it, and I'm like walking in the other direction.
Yeah.
Really, it's not that I don't care, it's that I really do care, and if I get involved, I get more crazy.
Mhm.
Because I don't understand it at all.
I don't either. I do not. My mom just likes politics. I mean, it's whatever. Like the people who were Trump's lawyers and everything,
Yeah.
who were helping, it's a family friend. So the person who, one of the people my mom mentored, it's her father-in-law and her husband's stuff. So like half the stuff that like the Georgia cases and stuff for like the fraud, he sued them and like, he caught a bunch of the things. But like my mom had not contact, but she was watching and keeping in touch and making sure, like, not keeping in touch, But the person she mentored, like she was asking her husband because her husband's probably knows that.
Interesting.
My mom knows. Just shoot. I was like at the beginning, like, so what are they doing today? And she's like, they're doing this. I'm like, okay, interesting. Like interesting, like they're going to court today. I'm like, okay.
Yeah, I purposely try not to worry or think about it. Like,
Yeah.
I don't know if that's smart or not, but
That was me at the beginning. Mm.
I remember one year. Do you remember the Hillary election?
Mm-hmm.
Me and my brother dressed up as Trump and Hillary. It was hilarious. It was really funny because at the time my brother was shorter than me and I was wearing heels. And so I was taller than Trump. It was hilarious. But now he's like taller than me, so it's really funny. Yeah, it was so funny because I was Hillary and my brother was Trump, so he got more candy than I did. I almost got no candy. It was hilarious. I was like, y'all are voting with your candy. And I'm like, bro, I'm just a kid. I don't actually go for Hillary. Like, chill. But it was hilarious. Oh yeah, I forgot I didn't know what the last one is on the homework. No.
Which one?
The,
Oh yeah.
The very last
Yeah, I
one where it
saw
says decide where the pattern has a line.
It's warmer in here.
That's in point six.
Oh, not there. You know, this is a women's jacket.
Yeah,
It's pretty good. It fits me better than the men's jacket, so I got the women's.
that's a good story.
But look, like, it has these cool ruffles.
Is that only the wing thing? Like,
I never understood school, honestly. Like, I never understood.
it's a women's
Rail?
jacket.
I guess it's crazy to me. Like,
Say
it's
this to
like,
your
they
mom.
have like scientific power.
No, I bought the women's jacket. I'm proud of it.
Oh. I don't see that at McDonald's where it's like, if you're a blind person, there's like braille at the drive-through window. Have y'all seen that? And it's like, what kind of blind person would be driving? And I'm
Dude,
gonna
have you
make
seen
braille.
dude, Lucas, have you seen the video of the kid? He's like, hi Arby's, my mom spent 3 years making this post. And I forgot a piece. He's so mad. I'll show you in a second. It's so funny.
For Lucas. This guy made the comment like, if you're a fat person, you're the bigger person. You're the bigger person.
Yeah.
And I'm like, oh no.
Don't freak out. You're the bigger. Wait, what?
I'm gonna cry.
No.
And what is
Actually,
it?
he's not that important.
Wait, who?
Philip Rivers is retiring.
Oh, yeah?
Bro, Drew Brees are trying. I'm more sad than that.
Dude, Drew Brees.
I guess the Colts are gonna.
He is old.
Dude, he
And he had broke ribs and had a crack wrong.
Dude, I'm surprised they weren't booing him out of there. Like, he was playing like trash.
Yeah, and this season was pretty bad. Like,
I watched that
Jameis
whole
was-
game. I watched every single game this weekend. The whole thing. Yeah. I had nothing else.
Dude,
You should have said that. I had nothing to do with
the
it.
case that Hill's gonna take that quarterback spot
Women's
now.
is out of town.
Dude, I don't believe
Oh,
in
you could have said
Jameis
something. All
Winston.
that came out.
Jameis Winston is not good.
And then we both could have watched it.
Women's.
Dude, did you see the thing? Everyone on social media was going nuts over Jameis Winston's touchdown pass. I was like, bro, he was just wide open by like 10 yards.
Bro, I don't know
It's
why.
because that's the only way he's gonna give.
No, he still had the most touchdowns in the league
But
last
he
year.
likes crab legs.
Had the most
What?
interceptions too.
He likes crab legs.
Who's that?
Jameis Winston.
Sorry, Jameis.
Don't you remember about him getting arrested for stealing crab legs from the grocery store when he played in Florida?
All I know is like my grandfather tells me all the time.
Like what happened in Florida.
My grandfather doesn't like Jimbo Fisher or Jameis Winston
Yeah.
because because Jimbo got him out of one.
How are you an NFL player and have to steal crab legs?
Well, it was when he was playing in college. He was playing at Florida, but he was accused of all kinds of stuff at Florida, and they get him out of trouble. But yeah, he got arrested for stealing crab legs from the grocery store.
Yo, big man, can I get this for free?
That was the whole thing. Is that was the arrogance of him, like that he would steal crab leg. I mean, like seriously, you can't even pay for your groceries.
That would happen in Florida. Like, it really would.
All righty. So that was number 35. Did you have any more on this section, Claire Jane?
But I was going with the pink.
No, ma'am.
Okay.
Yes, I was. Sleep out there.
What time did you go to bed? You don't know? Okay.
Like, are you-
6'9", but then I have to make it sound
Bro, that's so bad.
like I'm writing a song for 6'9". They're gonna go.
They'll be like, yo, that's fine. That's bars.
And everyone behind me is like,
Wash your shirt. It's
Oh,
cold in my
the
house.
sing team. The sing guy be like, dude, I just dropped 24 bars. That's it. You just have that. I have like 3 words in it.
yeah.
All righty. Moving on to 7-4. Were there any other questions on 7-3?
I do not think so.
Anybody?
I do not think so.
7-4 translations and vectors. And so we talked about how a translation, another word for that would be a slide or a glide. It just looks like it has either gone diagonally, up, down, back, or whatever it is. It's still exactly the same direction. Everything's the same about it. But we also learned that in Theorem 7.5 is that a reflection, a translation can also be looked at as 2 reflections over parallel lines. So remember a moment ago, we said a rotation was 2 reflections over intersecting lines. This time we have 2 reflections over parallel lines, okay? And we talked about how from one of my parallel lines to the other, this is called our distance. That's what this is telling me right here. Okay, so the distance from here to here, that's my distance. But when I look at that, to go from one point to the other or through the other to the other, that total is 2 times D. Okay, so from Q to Q prime to Q prime prime is 2D, or from P to P prime to P prime prime is also 2D. So if I know the distance between my parallel lines, then I know the distance from my pre-image to my final image is 2 times that number. Or if they give me the total from my pre-image to my final image, then I can divide by 2 to find the distance between the parallel lines. Okay, so I got to remember that. Now we turn the page to page 422. 422 gave us some examples dealing with that, where I look at and I can see my distance between my parallel lines is equal to 2 times the distance from pre-image to my final image. Then on 423, we went on to look at translations in the coordinate plane. And we talked about how when I'm doing a translation in the coordinate plane, I start with my original ordered pairs. So usually it's going to tell me that I've got a figure and this is where it's located at these coordinates X and Y. So in this particular example, they told us where A, B, and C were all located. Okay, they told us A is -1, -3, B is 1, -1, C is -1, 10. And then they told me that my translation is X minus 3, Y plus 4. So what I do is I substitute -1 for X, -3 for Y, and whatever my solution is my A prime point. I plug in my ordered pair for B. I subtract 3 from the X value. I add 4 to the Y value. That gives me my B prime location. For C, I start at 1, 0. I subtract 3 from -1, 0. I subtract 3 from -1, that gives me -4. I add 4 to 0, that gives me a +4. So that tells me where C prime needs to be located. Okay. So with a translation, I am looking at what did they tell me? Now tell me, when I'm looking at my X values, is X a horizontal or vertical movement? My value of X in an ordered pair,
Vertical.
is that horizontal or vertical? Think about your coordinate grid. Which one is my X axis?
Horizontal one.
The horizontal. So if I'm adding or subtracting from X, I'm determining my horizontal movement. Y is my vertical movement. So if I subtract 3, that means I'm moving left 3. If I add 4, that means I'm going up 4. So remember my positives and negatives. If this is a positive, I'm going to the right. If it's a negative, I'm going to the left. If it's positive, I'm going up. If it's negative, I go down. So that's what these are telling me. It's the orientation from, okay, I started with my pre-image point, and then am I going to the right or left? Then am I going up or down to get to my image? Okay, so I have to look at those to determine. Or sometimes they'll give us 2 points and say, hey, how did we get from this point to this point? And I have to look and see, okay, what is the difference in my X values? What is the difference in my Y values? And that tells me how I can find that formula there. Okay. Then we started talking about vectors. We said a vector looks a lot like an array, where I have the beginning point and then I have the side that goes with the arrow. We said my beginning point is called my initial point. It's where it starts. It's where my vector starts. And then my terminal point is the side with the arrow. So when I'm talking about component form just says, how many places to the right or left do I have to move? And how many places up or down do I have to move? So the main thing to remember is that, and actually component form usually has it kind of like a little shape like that. So basically in this situation, since I moved 5 units to the right, that's a +5 in my X value, because remember X is horizontal. Since I went 3 units up, then that my Y value is 3. So component form is like writing an ordered pair, but I'm telling to get from my initial point to my terminal point, I'm going to look at my horizontal first and then my vertical and write it as an ordered pair. Okay. So let's go ahead and take a look at the homework for 7.4. Any questions in homework 7.4? 7.4, any? Okay. Anybody else 7.4? Awesome. All right, 7.5. 7.5, we were dealing with glide reflections and composition. So basically we learned that a glide reflection is when I'm combining 2 different movements. What 2 movements make up a glide reflection? Translation is my glide and reflection. Okay, easy enough. A glide reflection is where it translates first and then it reflects. Okay, so it slides or glides and then flips. So we learned that with a glide reflection, order does not matter. It doesn't matter if you glide then flip or flip then glide. You're going to have the same pre-image and your final image is going to be exactly the same either way. But with all other combinations, order does matter. So to me, it's better just to go ahead and say, hey, order matters. And I've got to do them in order every single time I do it. Okay. So basically, we've learned how to do a reflection. We've learned how to do a rotation. We've learned how to do a translation. So now we're just combining them all together. So I go from a pre-image to an image, and then an image to another image. So basically I go pre-image is my single letter, my image is going to be my prime, and then my second image will be prime prime. And so I gave you guys for rotations around a 90-degree counterclockwise or clockwise, we looked at how we actually have some formulas to follow, and then that way we don't have to actually map it on the grid. to find those answers. So that's something that is helpful. All right, so we also learned that because each transformation is an isometry, then anytime I put two together, it's still an isometry. Okay, so I'm not going to be changing distance or length, angle, anything like that. All righty. Then sometimes we are given a picture and we are told, okay, given this picture, what are the examples? What happened first? So we always know that we're looking for a single letter to happen first. And then, so I'm comparing my single letter variable to my variable with my same variable with the prime symbol. And I'm looking to see, okay, what happened here? So we saw that the first one was a reflection, but the line of reflection was right here. And they told us that that was x equals 2. So I can see my first was a reflection over x equals 2. And then we can see that this was a 90-degree counterclockwise rotation. And we can see that my rotation happened about 0.20 because we can see that this was the point that it rotated about. Okay. So let's go ahead. So 7.5. Clara, you said you got number 13 and 15.
Yeah, 13, 15, and.
Okay. So the first thing that we've got to do is notice what my directions say. Sketch. Okay. So for numbers 13 or for some, so number 17, I'm sorry. Sketch on that one too. 13, 15, 17, 19, all of these, you should have sketched them first. You should have drawn them on graph paper to help you be able to look at them. So for number 13, notice it said my first move is a translation. So I'm starting with the original point of -3, 5. If I'm translating using this formula here, I'm going to take my x value, which is -3, and add 4. What is -3 plus 4? 1. Then I take my y value of 5, and it says I'm going to add 1. So I'm using this right here to tell me what is my transformation, what's happening here. So my ordered pair now is 1, 6. Okay, so the first thing I have to do is I've got -3, 5. And so then A prime is 1, 6. But then they tell me now I need to have a reflection over y equals -2. So what I'm going to do is I'm going to go, let's see if I've got this one. Yep. Okay. So the first thing we did is we said for letter A, we started out at our original, this was A, and it was -3, 5. And then this one was the one where A prime was 1, 6. So I've plotted point A, then I plot point A prime.
What is 1, 6? Oh,
We just did that calculation where we added 4 to X and we added 1 to Y.
we're supposed to graph that one too.
Because now that we've got that point, our next move is a reflection in y equals -2. Okay, so think about y equals -2. Remember, if I don't remember, then if y equals -2, that means my ordered pair, x is 0, y is -2. So I can graph that point 0, -2, and that's what this one is right here.
Is it okay if we didn't sketch it? Because I didn't have graph paper, but I could see like I understood how to do it. Is that okay or not?
It says it on the homework to sketch it.
Well, I mean, it's the kind of thing where how are you able to do your reflection over y equals -2 if you don't have, and if you need more graph squares, let me know and I can copy some for you. Okay, or I can email them to you or whatever. So you're going to need graph paper for this class. So make sure that if you don't have any right now that you get some so you've got it, or let me know and I can email you some grid squares to print out or whatever. Okay.
But
So
is it like required to sketch it?
I mean, if the directions say sketch it, and if you have to sketch it on a test and you haven't done it through your practice and your homework, how are you going to know to do it on your test? Okay, so I mean, it's all practice. So So here we have ended up at A prime at 1,6. My directions now said I need to reflect over the line y equals -2. So I plotted my point 0,2 and I draw that as a horizontal line. So this is my line of reflection. So what I've got to do is I've got to look and say, how many units does it take to get from A prime to my line of reflection? And you can see here that I had to go down 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8 to get to my line of reflection. So if I had to go down 8 to get to my line, now I need to go continue and go 8 to the opposite side. And here is my point, A prime prime. So my line of reflection, I'm counting how many units does it take to get from my original point to the line. So if it took 8 units to get to my line, then I have to go on the opposite side another 8 units.
So you're going from point 1.6 down to the reflection.
I go down to my point of reflection and I graph it, and then I have to determine what is that ordered pair. When I graphed it, where did it end?
Right below the FB point 1 -2.
And not 1 -2. Remember, this is, I've got to start at my origin. So if this is my origin right here where X is, that's my origin. So what is my ordered pair for A prime prime? I go to the right one, but then I go down 1. Oh, I'm sorry. I didn't start at my origin. Let me go back. Let me erase so we can. If this is where A prime prime is, I've got to go back to my origin. Oh man, did I erase it?
How did you find A prime prime?
Okay, so that's what we just did.
Okay, I don't understand.
Okay, so let me draw my line back.
Thinking that y equals 2 is -2. It's like it would -2, not 2. It would be 1 -2 if it was reflected in y equals 2 versus 8.
So do you get how we got 1,6?
Yes.
Okay, so we did the transformation there and we got to 1,6. Okay, so we plotted that point. Okay, so now it says that we are reflecting over y equals -2. Okay, so do you see that part of the directions? So now in the book, it says the underneath translation, if you're on page 433, number 13. The first thing said translation, and that's what we did to get to 0.16. Then underneath it, it says now I need to do a reflection and y equals -2. Okay, so now what I've got to do is I have to draw that line y equals -2.
Okay, so it's reflected across the x-axis.
No, it's not reflecting across the x-axis or the y-axis. It's reflecting in y equals -2. My x-axis and y-axis are already there. It would be much easier if I was just reflecting over my x-axis. But that's not what my directions tell me. My directions tell me I have to reflect over the line y equals -2. So I have to draw that line. It is not given to me. I've got to draw it.
Okay, I have it drawn.
Okay, so we've got to draw y equals -2. So that's what this point is. I plotted point 0, -2. So that's what this is right here. This is 0. Get the wrong thing. Okay, so my yellow line here is my line of reflection.
And it's going to be on the y-axis.
No, honey, it's 2 places below the y-axis. I mean, below the x-axis.
I know that's where I have it. Oh, I mean, it's going to be on the y line.
Yes, it is. It is going to fall on the y-axis because yes, it is it's the y-intercept.
Okay.
Okay, it's a y-intercept, so it is intersecting the y-axis.
Okay.
So now I'm looking at where I'm starting at A prime. Okay, so if I've got to reflect over my yellow line, I'm looking to see how many units do I have to go down to get to my yellow line. So look on your graph because it's not showing up very clear. You can't see it real well on the screen. how many units down do you move to get from that point at A prime to the yellow line?
8 units.
8 units, okay? So if it took you 8 units to get down there, how many units do you need to go below the line for the reflection?
8 units.
Go down 8 units. Now, once you plot that point, I need you to tell me what the ordered pair is for A prime prime.
One comma -8.
Not -8, because when you counted, did you go back to your origin?
No, okay, we're at -2. -10.
Good. So 1, -10 is your ordered pair. And that is your final solution. So first I had to translate. So I had to go from A to A prime. Then I had to reflect over y equals -2. So I had to draw that line of reflection. Then I had to look to see how many units do I have to move down from A prime to get to my pointer, my line of reflection. So if I went 8 units down to get to my line, I've got to go 8 units below. And then I plotted that point, and then I went back to my origin to count up my ordered pair for that point. And so my solution is 1, -10. Okay. For 13, I've got to do the same thing. I have a translation first. So I start again at -3,5. And so my translation, I go from -3,5. Now I need to subtract 3 from X and subtract 3 from Y. So the first thing you do is graph or plot A, which is -3,5. And then if my translation says I need to subtract 3 from X, how am I going to solve? How do I figure out what X is?
You go down.
No, so I want you to go back here. Notice here, if this was my original ordered pair, -3,5. -3,5 was my original ordered pair. Okay. My translation says I have X minus 3. So what is -3 minus 3?
0.
Nope. -3 minus 3 is -6.
Okay.
-3 plus 3 is 0, but -3 minus 3 is -6. Then I have 5 minus 3.
5 minus 3 is 2.
Good. So my new ordered pair is -6, 2. So plot that.
Okay.
That's step 1. That's my translation. So now I've got to plot -6, 2, and this is A prime. Okay, so that's -6, 2. Now the next one says I've got a reflection in y equals x. So basically, instead of I had y equals x, okay? So now when I reflect and I have, if I've started out with x, y, and now I'm reflecting y equals x, I'm taking the opposite there. So basically what I've done is I have -6, 2, and then I just flip-flop them.
Okay, so you would have 2 comma -6.
Yes, so that is my A prime prime location, is 2, -6. So then I plot that. And that's my final solution.
And that would be A prime prime.
That's A prime prime.
Okay.
Okay. So you're doing the same things for 17, 19, and 21. Okay. So what I want to do is I want you to work after we've gone through those 2. I want you to go through the same thing, except for look, number 17 says you're going to reflect in the y-axis, so you don't have to figure out any other line. Number 19, now you're going to do a rotation 90 degrees about the 90 degrees clockwise about the origin. That's when you're going to pull out those little formulas that I gave you. 21, it says to do it one way and then do it the opposite, do it reverse order and see if your image turns out differently. Okay, so you're just going to do the same thing that we just did. Graph your original pre-image, do your image, and then your second image and look to see. Okay. Any other questions from 7.5? Any other questions from 7.5? All right, and then 7.6 was dealing with our freeze patterns. So we talked about how a freeze pattern, again, can be a glide reflection, it can be a translation, it can be a composition, it can be any of these things. And we see on the first page where each movement, each transformation has a letter assigned to it. So a translation is T, 180-degree rotation is an R, a reflection in the horizontal line is an H, reflection in the vertical line is a V, and then a glide reflection is a G. Remember, glide reflection is the combination of a translation and a reflection. So basically each movement is assigned a letter, a variable to represent that movement. So then when we turned over to page 438, we can see that they have given us a chart and they've given us examples of what all these movements look like. Okay. So they gave us examples on what each of these movements look like. And then part of our work was to determine based on an image. So notice my translation noted by just a letter T. And each little comma or little apostrophe, whatever you want to call it, upside down comma or an apostrophe, it looks exactly the same for each movement. Then we have a translation and 180-degree rotation. And that's where we can see that's letter TR. And we can see that it would translate, rotate, translate, rotate, translate, I'm sorry, reflection, translate, reflect, translate, reflect. So we can see that's what a translation and a reflection would look like. The next one is a translation and a horizontal glide reflection. We can see how these two are different. Notice my translation and a reflection, now my little figure is facing the opposite direction. Whereas a translation and a rotation, it's still upside down now, but they're facing the same direction. So you can kind of look based on the movement, based on what the figure looks like, you're able to figure out what kind of movements are taking place. Okay, so that's with freeze patterns. Any questions on homework for 7.6?
Number 61 in the mixed review.
Okay, in the mixed review, number 61. So that is going to be on page 444. Okay, so let's take a look at that. And we've got to think back to when we were dealing with our triangles. And what was our formula? Think about when we talked about where our angle bisectors meet in the middle. Okay, so I can see that I've got my bisectors here. And so remember, we had a formula that told us that from here to here is a certain fraction, and from here to here is another fraction. It's 2/3, okay? So I know that I've got that 2/3 distance here, okay? So if I'm solving and I've got, basically I've got 2y, and then I've got to solve for the other little segment, okay? So let's see. Let me erase real quick. All right. So in this one, I've got 2y is my first little segment, and I've got 3y minus 4 is here, okay? So what is my total segment measure? No idea? Okay, so my total measure would be 2y plus 3y minus 4, right?
Well, I did that and I tried to set it up as 2y equals 2/3, or 2y equals 2y.
Okay, so I've got to say that Hold on a second. Let me do this real quick. So I know that 2/3 of that, let me change that to the other side. So 2/3 of my total segment equals 2y. Make sure that's not falling. Okay, so now what do I need to do to get rid of my fraction? How do I eliminate a fraction? What is a fraction a type of problem? It's division, so how do I undo division? Multiplication, so I'm going to need to multiply both sides by 3. So what do I have left with when I do 3 times 2/3? What's left? 2, because my 3's cancel out. So I have 2 times 2y plus 3y minus 4 equals 2 times 3 is 6y. Now I have to distribute, and 2 times 2y is 4y, plus 2 times 3y is 6y, and 2 times -4 is -8, equals 6y. So 4y plus 6y is 10y minus 8 equals 6y. I'll subtract 10y, subtract 10y. -8 is equal to -4y. Divide by -4, divide by -4, so y is equal to 2. So if y equals 2, then I can see that my whole measure, I could plug it in and find the total distance of that. Okay, so I'm going to do the same thing for w and w minus 4. I know that 2/3 of w plus w minus 4 is equal to w. Again, I'm going to multiply by 3 to eliminate my fraction. So 2 times w plus w minus 4 is equal to 3w. So now I can distribute. And I have 2w plus 2w minus 8 equals 3w. So I have 4w minus 8 equals 3w. Subtract 4w, subtract 4w. -8 is equal to -w. Therefore, w equals 8. Okay. So, like I said, the reason I'm starting to assign the mixed review is because I do not want you to lose the skills that we have previously learned. These are things that you need to remember, okay? You've got to remember first and foremost how to clear a fraction, how to get rid of the denominator. Multiplying by the denominator gets rid of the denominator. Whatever I have left in the numerator is my numerator, okay? Unless I'm multiplying by a different number. But then also understanding that when I'm dealing with my angle bisectors in a triangle, that when I have that, I know that from the point to the point of intersection in the middle, my end center, I know that it's 2/3. Okay, so I have to remember these formulas that I've previously learned. If you don't remember, look back to the text, look back to your previous work, think about what you did previously. So any other questions from 7-6? All right, so let's look at our chapter review. So again, starting on page 446, 7-1 says rigid motion in a plane. Okay, and it says, does the transformation appear to be an isometry? Look at number 1 and 7-1. Does this appear to be an isometry?
Yes.
Yeah, it looks to be the same size, looks to be everything the same. It's a reflection, it's reflected over that line, it's just faced in different directions. Look at number 2, isometry or not?
No.
Why?
Different sizes.
We're on page 446, under 7-1.
Different sizes.
They're different sizes. So I can see that these are not the same size, so this is not an isometry. What about number 3?
It is.
It is. And what type of transformation has happened here?
Rotation.
A rotation. Good. All right, let's look at 7.2. It says in the diagram, AB is reflected in the line y equals 1. So you can see that they drew the line y equals 1. So we look at our reflection. Remember, anytime I'm trying to do a reflection, I look to see how many units does it take to get me from a point to the line of reflection. So I have to go the opposite direction that many units. So for B, 1, 2, 3, 4. Oops, so wrong one. 1, 2, 3 to get to my line of reflection. So I go the opposite side, 1, 2, 3, and plot my point. Okay. So now let's take a look at number 4. It says copy the figure and draw its reflection in the line. So basically, we're not going to take the time to put those on a graph, but just think about what the reflection would look like over line K. So remember, sometimes we'll have a line that's going to be one of the lines that we're given. Sometimes we have to graph them. 7.3 on page 447. In the diagram, triangle FGH is rotated 90 degrees clockwise about the origin. So remember, if you're having to rotate about the origin, then you can think about as this is your point of rotation right here at the origin. So I'm having to make a 90-degree angle. So basically, I'm going from my original point to my point of origin, and then I know it has to make a 90-degree angle. Now, again, I gave you the formulas for rotations. Okay, so you can use those. So that tells me where my points need to be if I do a 90-degree rotation. So remember, from H to my point of rotation to H prime is 90 degrees. From G to my point of rotation to G prime is going to be 90 degrees. From F to my point of rotation to F prime will be a 90-degree angle. Each rotation is 90 degrees. All right, the next ones are using a straight edge and a compass. We're not going to worry about that right now. Look at 7.4, translations and vectors. So we can see where it says using vector -3, -4, triangle ABC can be translated to triangle A prime, B prime, C prime. So notice if this is my vector here, if my composition form is -3, -4, then I start with whatever A is, subtract 3 from my X value, subtract 4 from my Y value, and that gives me my prime. So I use these numbers. So whenever I see these two little kind of arrow things, I know that this is composition form. I know that this is where I'm going to use this instead of it being, basically what this means is X minus 3, Y minus 4. These mean the same thing. We were used to seeing where it said X, Y, and then we translate to X minus 3, Y minus 4. When I see this, these are the same exact thing. If it says to use this vector, then I'm going to start with my X and Y value, subtract 3, subtract 4, and I get my new values for A, B, and C. So same thing for numbers 10, 11, 12, 13 here. If my vector is 0, 3, that means I add 0 to X, add 3 to Y. For the next one, I would subtract 2, add 5, add 4, subtract 1, add 2, add 4, okay? So knowing what those symbols mean are going to help you to be able to draw your translations. 448, glide reflections and compositions. Remember, this is where I have a combination of 2 or more movements. A glide reflection is 2 movements in itself. And so remember, if it has a translation in this point, they are going to put it in this form. So this is where I would start with whatever my X and Y values are. This tells me I have to add 4 to X and I keep Y the same. So for each point of that figure, I add 4 to X, keep Y the same. Then it says reflection in the line, Y equals 3. I would have to draw my line of reflection, Y equals 3, reflect my A prime figure over that line to get A prime prime. Okay. And then our freeze patterns. Freeze patterns, basically I'm looking at it to see what I've got going on here. And I'm having to think about all of my different letters. So, looking back at page 438. Basically for freeze patterns, looking at 438, trying to figure out what the combinations are there. So what I would do is, I will, if there's one of these on the test, then I'll give you a list to choose from. Okay, so you don't have to recall exactly all the letters. I'll give you the list to choose from on that. Okay. Questions at this point? Any questions? Okay, so what I want you doing is any corrections you need to make to chapter 7 work. Okay, any review that you need to do for questions. Now, one of the things I want to tell you is now on Wednesdays, this is my only class on Wednesdays. But my plan is to go ahead and stay through the afternoon to go ahead and get work done, to be able to grade papers, to use this time. So I will be in here. So if you have a class after this one, but then you're done at 12, if you need to stop back by and see me, I will be here. Okay. If this is your only class and you need to stay after class to get help, I will be here. My main thing is on Wednesdays, if you have questions, please let me know, and we can schedule some time if it needs to be beyond what I'm here. If I need to stay even longer, I'm happier to, so I can be here when you get out of class at whatever time. But if you need individual help, please let me know, or if we need to set up a Zoom, we can do that as well, okay? This is the most abstract we've been so far this year. And what I mean by that is we're having to really picture these movements and things in our mind. If it helps you to actually draw a picture, I was working with somebody the other day and we were doing something and I actually drew the picture and I was like, okay, so now if it turns like this, what does it look like? If you need to draw the figure, cut it out and turn it and move it. That makes it more concrete. Sometimes our brains are having trouble figuring these things out. So if you need to make it concrete, you can always draw the figure on paper, cut it out, and then move it the way it's telling you to move it. If you have a coordinate grid, then you could lay it on there and move it the way it's telling you to move, okay? But this is the part of our brain learning how to go from concrete to more abstract. It's a learning process. Just be patient. It's a struggle. It's hard. Again, geometry is a whole different set of vocabulary, so it's a big change in itself, okay? Tomorrow, we will be starting on chapter 8. I will give you the chapter 7 test. Okay, and so chapter 7 test goes home tomorrow. It will be due on next Wednesday. Okay, so you'll have a week for that. I will also be getting test corrections back to you this afternoon, so look for those to be due next Wednesday. And then we'll start chapter 8 tomorrow. If you need help, please let me know. We've got probably about 4 minutes before the bell rings, so just hang tight for the bell to ring. If you need help, let me know. Are you ready to turn it all in? Awesome. If you want to get rid of your work, now do you want to keep it to study by or are you good?
I'm good.
Okay, because if you want to keep it to study, don't turn it in yet, so you'll have your notes to study and everything like that.
I'm good too. And also, my mom
But
forgot.
is this all of your homework? What about the
Yeah.
homework that your dog gave you?
That was a note.
Oh, your notes. Okay.
My
So you
mom,
have your homework.
yes, ma'am. My mom is bringing the tuition.
Okay.
She's right on the way here. So
Okay.
are you gonna see?
Yeah, I'm gonna be here. I'm gonna be here for a while.
Alright.
And then also real quick,
Anything
well,
else?
I'll wait and pass back papers tomorrow. I won't, a lot of y'all have already packed up, so I'll wait.
I'm only trying to see.
Well,
part of the homework
by myself.
Perfect.
It's just 7.1 to 7.3. I gotta review 7.5.
Well, go ahead and hang on to it and turn it all into me at one time, because I don't wanna misplace part of it. I wanna keep it all together.
Can I move this?
What if you want
All right, Keely, if you're still there, if you have any questions, be sure to let me know. If you need any help, be sure to let me know. And I hope you have a good afternoon and feel better, and we'll talk to you soon, okay, babe?
Yes, ma'am. Thank you so much.
All right, you're welcome, honey. Let me know if you need help.
Thank you. Bye-bye.
All right, bye-bye.
Like,